post lab for easy as pie. So hopefully when you started your lab, you sat down and you actually did your formulas and you did your type of bonds and you discovered that we had two substances that were ionic, three substances that were covalent, because we know that covalent substances start with carbon. That also gives us some important properties from the get-go on this, okay? As soon as you saw the term ionic, hopefully you were thinking that these had higher conductivity, soluble in water, okay? General characteristics, by the way. These are also going to have higher melting points, boiling points, okay? We know that covalents, they're going to have lower boiling points, melting points, less soluble in water, okay? It's a general characteristic of it, okay? And low conductivity. So as soon as you see that you have the difference ionic and covalent, you already know that much about it. So that was supposed to lead you with your procedure on what you were testing. And so hopefully some of you use your conductivity probes, some of you looked at solubility on all that kind of stuff. So let's look some more at this lab. Okay, so we had our suspects, and here's some things. So procedure, we talked about procedures. So you write them out like a list. And this is a possible procedure you could use. Um, Adding a small amount of water to a small amount of powder sample in a small beaker or a cup and mix them together, record your observations. Use the conductivity tester and the powder water mixture to see if it conducts electricity. You add a small amount of the powder to a spot plate. You put a little bit of vinegar in there because that's a weak acid, and see how it responds. And then you add a small amount of powder to another spot of the well plate and add iodine. Because you have a starch, starches will react to the iodine. That would be a telltale sign for that. And then repeat for your sample. Okay. You could have also used pH paper instead of reacting with vinegar, which the vinegar would identify your baking soda, which is basic ionic compounds. Baking soda, salt will conduct electricity when dissolved in water, and covalent substances won't. Like I said, only the cornstarch should react with iodine because starches react with the iodine. And the other thing is that when you put the cornstarch with the water, it forms what you guys would have known as oobleck, which is a non-Newtonian fluid. And so this is a sample of a data chart that you could have brought in and written up. It's very plain, simple, straight. Depending on how I set the scenario up, if it's cornstarch, right? Um, I'll identify who these are because this is scenarios based on someone else's. Oh, sorry, no, this is the right one. So if it's cornstarch, then that's Betty. If it's baking soda, then that's Gladys. If it's salt, then it's George. The powdered sugar is Millie. And I just threw the flour in to see what you would do with it. It was actually flour is found in pretty much everybody's kitchen. So let's talk a little more about this. This is a review over your periodic table and properties and trends and all of that. So periodic tables and knowledge that is important. Um, Also, it's always good to go back over your law of conservation because we ended on balancing equations. We're starting there again. We're getting to stoichiometry. Law of conservation mass tells us it's neither created nor destroyed. Um, so what I start with, I've got to end with. Okay. No new elements may appear or disappear. Okay. What I start with, I end with. Um, and then we have the type of bonds I can have. I can have ionic, I can have covalent, and then I can have metallic. We don't really talk much about metallic. We focus really on your ionic, which is a metal and non-metal. And we also worked on naming compounds, the difference between those two. There's just flow charts to remind you about that. Remember that covalence will require prefixes, okay? And also another thing about covalence is that they can have multiple bonds, all right? And Again, some more on the type of bond because we're still working on that. Ionic, we're going to have electron transfer. That's also why it conducts electricity, because you have that transfer. Covalent, they're sharing it, so there's nobody really fighting over a charge. Okay. And just some more charts going over your types of reactions. We talked about that. We have synthesis, decomposition, single replacement, double replacement, and combustion. Synthesis, two are becoming one. Decomposition, one is breaking down into two or more. Single displacement or single replacement, I have somebody by themselves on one side, and all of a sudden I got a partner on the other side. Okay, we saw that usually with the nail and the copper sulfate is a typical lab that we do for that to showcase that. Double displacement or double replacement, I have everybody's got a partner, and on the other side they got new partners. So we did that when we put any of the mixtures together. So silver nitrate and copper sulfate is one thing we put together. Usually they're going to be our dropper bottles we're putting together. And then combustion reaction, every time you light up your Bunsen burner, that's a combustion reaction. Okay. Exothermic versus endothermic. Exothermic, that heat is being given off, it is releasing, versus endothermic, it's going to feel colder. Bond making versus bond breaking. What this is really getting into is when we do a reaction, we're going to make and break bonds, and so that energy transfer is happening within the bonds. That's the only way that you can have a reaction. And so one of the things we have to look at is what are the intermolecular forces that are playing a role onto keeping that compound together. Because the stronger the force is, the harder it is to break those bonds, which means more energy I got to put into it to break and make those bonds. So intermolecular forces play a role. Usually your ionic interactions are stronger than your intermolecular forces present in covalent bonds, which explains why ionic bonds have higher melting points, higher boiling points, and covalents melt very quickly on the hot plate, okay, because it's intermolecular forces. And just a little bit more on that, these are more images, your ionic versus covalent versus metallic. Metallic, the reason metals conduct electricity is because your electrons are free to flow in somewhat ways. They call them like a sea of electrons. They move like the sea, okay? And that is it for your very first opening lab for the new semester. I hope you learned a lot and remembered a lot from the first semester, and I look forward to a great semester 2. Live long and prosper.